Your son marches to the beat of a different drummer, but don't worry, we'll have him joining the parade by the end of the term.
Class?
It's an education beat. The little boy went first day of school. He got his crayons and he started to draw. He put colors all over the paper. All colors was what he saw. And the teacher said, "What you doing, young man?" "I'm painting flowers," he said. She said, "It's not the time for art, young man. And anyway, flowers are green and red there."
Okay, so again, I'm not cool like Murray. However, come on, that song is awesome. All right, so today we're doing graphs of polynomials, and as a little Halloween treat, decided to shorten it a little bit because I don't want this to seem more complicated than it is, because it isn't that complicated. So the paper that you're looking at, maybe you freaking you out a little, you look at the back, you're like, oh my god, what's that? Don't worry about it. We're just going to learn the easy way, I guess you could say, and the way that you need to know it. I guess when I designed this, I think I made it a little bit more complicated than it needed to be. Okay, so we're going to find the key features of graphs. Tables. So we have graphs here, we have a table here, and we have a whole equation there. So you have to be able to look at the three and be able to compare them in some way. So we know how to find these key features. We know x-intercept, y-intercept, maximum, minimum. This is just maximum, minimum is just plural for some reason. Instead of putting S's or ES's, they put an A. Okay? You guys probably know better why. Relative max, relative min, roots, and degree. Now, we just spent a whole week talking about those things. So you know how to find them, and you know how to find them for graphs. You know how to find them for equations. Tables, well, it's just numbers, so the tables aren't that bad either. So we just want to look at these graphs and compare them in the way that you're asked to compare them. So if you look down here, create an inequality comparing the relative minimum of the graph and the equation. So first of all, they say compare each of the following in the interval -1 to 2. So that means when we're doing the relative minimum and relative maximum, or whatever we're working on, we need to look at only between, pick blue, -1 and 2. So this interval they're talking about are the x values. Okay, so here, nice enough, -1 to 2, they did that. And this one, you can either put it in your calculator and look at it, or you can create a table of values like this. It's up to you. But they want you to compare. Oh, I picked the wrong thing. They want you to compare this graph and this equation. Okay, they didn't mention the table, so they want the graph and the equation. So they want the relative minimums, and they want you to compare them. All right, so relative minimum for the graph, look at that, it's right on the border of the interval that they want. So that looks like it's -2, -6. So this one, okay, nice, Barris. So it's +2, -6. And then this one, how do we do this? Now, again, you can put it in your calculator and see. We know it's a parabola, and we know it's face up. You know, it's up. It's like a U because this is positive. So we know that it does have a minimum. But you also know, if you take yourself back to last year, that the minimum falls at the axis of symmetry. The formula for the axis of symmetry is x equals -b over 2a. So -b, this is b, So negative b would be positive 2 over 2a, which is 1. So 1. So that's the x-coordinate for the minimum. So if we plug 1 in, let me just erase a little bit. We know the x-coordinate is 1. Plug it in, find the y-coordinate. 1 squared minus 2 minus 4. So that would be, I can do this, negative 5. I thought I had this done, but apparently I didn't. So negative 1, 5. Or positive 1, 5. Wow, I'm awesome. So these are the two. And when we compare maximum and minimums, we generally compare the y values because that's the lowest that they go. Okay? The x values are great, but since it's minimum, the y value tells you how low you actually get. So this one is smaller than this one, so the inequality would be a, because we're in graph A, is less than C. It's good enough. Or yeah, that's fantastic. That's all you have to do. Which function has the most roots? Next question. So which function, I'm just looking for eraser. So which function has the most roots? Okay, great question. And I can't use the eraser, so let's use a different color. So the roots are where it hits the x-axis. So 1, 2, 3 for this guy. So this guy has 3 roots. I got that. This one, how many times does it hit the x-axis? So when it hits the x-axis, the y is 0, so it only hits at one spot, so this has 1 root. And this one is a parabola, so you know the most it can hit is 2, because the degree is 2. So which one has the most roots? Well, A has the most roots. The graph. I don't have to find what these roots are here, because I know that the most it could possibly have is 2. Awesome. And look at this. Number 1, same as 3. Whoop-de-doo. Okay, this one down here. Which one has the greatest average rate of change? Well, we haven't talked about that yet, so we're going to do that in just a second. So let's just talk about what are the y-intercepts. So y-intercepts pretty straightforward. Just look at them. Y-intercept for this guy is 0, 0. Y-intercept for this one is where x is 0, so it's negative 4. And the y-intercept for this one, there's enough going on here, I wish I could erase it, but apparently I can't. No eraser! When you plug 0 in, you get negative 4. So the 3 y-intercepts are 0, 0 for the graph. The table of values was 0, negative 4. And the equation was 0, negative 4 also. Interesting. So those are the y-intercepts of each. Why don't they have more than one y-intercept? Now this goes back to, do you know what a function is? So a function, for every x value, you can have one and only one y value. So if there was another y value that went with the x value, so if there was another y value, let's say for the graph, like here, then you would have 2 y values for one x value, and if you remember, it wouldn't pass that vertical line test. So that's why it can only have one y-intercept. Pretty exciting. Okay, so the average rate of change. Now all this is great. This whole worksheet is awesome. These are all the things that we can find if we need to. So we can find x-intercepts, y-intercepts, and all this mess. But you already know how to do that. So to simplify things a little bit and try not to make it too complicated for you and for us, let's just discuss the average rate of change. Now you have done the average rate of change for lines quite extensively last year. This formula right here should look very familiar to you. That formula is the slope formula. Remember, M stands for slope. And the average rate of change you can do for any graph. Okay, for little curves and stuff like this, the curves may not go on a straight line, but you could figure out the average rate of change. And it uses the exact same formula. So all you need are 2 points, and you use the slope formula. So for each one, we're just going to go through, how do I find those 2 points, and be done with it. Okay? And then to compare them, you just compare them. Which one's bigger? Which has a bigger rate of change. So for the graph, remember, the interval that we're going through between -1 and 2. So that means the x-coordinates are -1. For the endpoint, for the slope here, the x part is going to be -1, and the other one is going to be 2. So to find the y, we just find it on the graph or wherever, whatever kind of thing we're doing. So -1 is right here, so it would be -1, 0. Okay, and then 2 is here, so that would be -6. So now we just plug it into the slope formula. Now you remember from last year, when you do the slope formula, it doesn't matter what point you start with as long as it's the first one for each. Okay, so I can start with this point right here. The x's, remember, the x's go on the bottom, the y's go on the top. So -6 on the top, 2 on the bottom. And then I take this point, 0, -1, and we put minus signs in between. So it's -6 over 3, and that's -2. So that's that guy's average rate of change. Let's find this one's average rate of change. This one's all nicely set up. Those are our points, our x and our y. Remember, f of x is just y. So y's go on the top, so I'll take this point first this time. Again, it doesn't matter as long as you set it up right. So -6 goes on the top, -1 on the bottom. And then for the other one, 0 on the top, 2 on the bottom. Subtract them. So -6, the average rate of change for this one is -6 over -3, and that's a +2. Last one. Down here, this one, a little bit more exciting. You have to figure it out, so you would have to plug them in. So remember, I'm going to come down here just so that I have more space for me. So I need to plug in -1 for the x value and also 2 for the x value. So when I plug in -1 to the equation, I get -1, -1. And when I plug 2 into the equation, I get, I'm just making sure I'm right here, I get -4. Okay, you can obviously check that if you want. Put it in your calculator. But for the sake of this lesson, those are right. Okay, so when we plug these in, I'll start with this one. Again, it doesn't matter what you start with as long as you start with that one for the x's and for the y's. So that's why I take one equation, put one on the top, one on the bottom, then go to the second equation, one on the top, the x is on the bottom, and then we put a minus sign in between. Okay, so -1 minus a -4, it's +3, and -1 minus 2 is a -3. So this one's average rate of change is -1. So we have 3 average rates of change. Those 3 average rates of change are, let's just go down here. Those 3 average rate of changes are, so for the graph, it was I don't know what the heck I'm doing. So it was, I forget. Let's look back up. Here we are. -2. For the other one, for B, the average rate of change was 2. And for C, the equation, the average rate of change was -1. So we have 3 average rate of changes. Which one is the biggest? Now that's the interesting question. Now, as we say, this one right here is the biggest number, but it's not the biggest rate of change. These two, if you think of the slope of the line, that connecting with a slope of -2 and 2, their rate of change is exactly the same. So both of these have the greatest rate of change. It's like a trick question. Now listen, if I messed up with some of the math, we'll live. But they're exactly the same. So which one has the greatest rate of change? A and B have the same exact rate of change. One is going up, one is going down, but they're changing at the same rate. All right, have a wonderful day. Hope your Halloween was great. See ya on Monday.